Welcome everyone to this talk on Chasing Simplicity, the Art of the MVP. Now, I work with Matt Jones, who you just saw, no doubt most of you still here from the previous talk. You just saw Matthew Jones's excellent talk on the vehicle art of our game at DPS Games. I'm the lead technical artist at the same studio, so now that you know the output of our pipeline, I'm going to talk to you about the drier, slightly more boring bit, let's be honest. It's about the pipeline itself, is how we produce this art. And a lot of that is we had to do from the ground up because, as we previously said, we're a brand new studio and we had to start pretty much all over from scratch. So what is this talk going to be about? We're going to talk about our texturing pipeline. How do we produce the amazing images that you see before you? Obviously, great tools help, but in the end, it's the artist actually producing the art. So we try to remove barriers between the artist and their art. We're going to look at the various phases of development that we went through in order to develop tools up to the level that they are today, and we're quite satisfied where we are today. And then we're going to look at some lessons and conclusions lastly. All in all, there's about 4 phases of development that these tools went through in the past 2 to 3 years to get to where they are today. So first, a bit about DPS Games. As previously mentioned, we used to be known as Wargaming UK, and were established as such in late 2018. We were then rebranded as DPS Games in 2020, and we got a mission from our illustrious parent company, Wargaming, to develop a brand new IP for the West. It was a vehicle game. It's a vehicle arena combat game. It's fantastical art, and when I got the call from Nick Payne as well, to lead the technical art team, how could I say no to that, especially after they showed me what it is that they were working on. A bit about myself. I'm Mattias. I've been in the industry for 10 years this year. It's been around for a while. And 6 of those years have been spent in tech art. In that time, I've shipped 6 titles, and 4 of them AAA. Spent a decent amount of time working on Total War, as you can see here. So before we can really dive into the meat of the talk, I have to go over some terminology. The idea behind chasing simplicity, for the software developers among you, you'll be familiar with the term kill your darlings. This applies to writers and authors as well. The idea of chasing simplicity is about taking that one step further. It's about kill your darlings is really only applicable to things that you want to remove when they bother you. Chasing simplicity takes that one step further by removing things before they start to bother you. But if you're suspicious, they might at some point, which also includes regularly pruning your tool space, removing anything that you're not currently using just to prevent it from sprouting roots into other systems that make it harder to remove later on. You'll see throughout the talk this symbol on the left appearing as well. This will be symbolic of any time that we've chased simplicity by removing a feature or simplifying a feature, and in some cases actually went backwards in terms of how many features our texture pipeline supported. All of that, however, was in the spirit of making a better pipeline overall, a simpler pipeline that puts fewer barriers into the artist's way between them and their art. MVP then is about minimum viable product, no doubt a very common term in game development as well. This is about, for us at least, this is about minimum work for maximum understanding. This is not a prototype. The MVP in this case is about building something that'll work and that'll hold up. It's very much duct tape. But what it allows you to do is focus on one aspect, a very small aspect, and really the core of the problem, and solve that aspect only and nothing else. And that allows you to solve each of the parts of your problem individually before you go on and move to a much larger, much more complex solution. Obviously, games are big, they're complex. Complex solutions are necessary, but that doesn't need to mean that they need to be complicated. A note about how we make our game then. We distribute a lot of our development. We share tools, and a lot of those go to remote and hybrid workers, which means we have to share the tools with them. We have to share our tools with wargaming partners, other wargaming studios that are helping us out. We also have distributed development partners, entire studios that are offsite, that are contracted out by Wargaming, and we share our art tools with them as well. We get entire art teams using our tools outside the studio. And then lastly, of course, we have external vendors, regular outsourcers. All of the above, each one of these receives a copy of the art tools that is very much uncensored in the sense that we remove very little for them as compared to the tools internal artists receive. As such, our goal was to have their development experience to try and be as similar as possible to the experience of an artist working physically in the studio. Our texturing pipeline, we can finally dive in now that we've got the terminology out of the way, requires a bit of understanding of what texture packing is. Now, most of you will be familiar with this, but just to give a bit of a refresher, in games, we use shaders. These shaders are very expensive sometimes, and one way to make them cheaper is to pack multiple grayscale images into a single full color image. This is a fairly common technique. In our game, obviously it's a big game, we had a requirement in one particular case to produce 8 individual white or black images that would become masks in our shader. And we really only had 2 options. Either we could put them in 2 full color images with a red, green, blue, and alpha, or we could be smart about it, and our graphics artists, fortunately, are very, very smart. They figured out a way to pack 8 individual white and black images into one single grayscale image by packing the bits. Now, obviously, authoring that is quite difficult. Substance Painter, which is our texture authoring package of choice for most of our artists, it's going to be hard to author 8 masks individually. Not to mention, Substance Painter actually doesn't support that many custom channels. So we had to come up with a color ID system. Now, already you can see this kind of conversion process. No artist is going to do it manually, or if we ask them to, they're going to jump out a window, which is obviously not what we want. So we knew we needed to make things automatic. So what we needed to do, first and foremost, was to remove any limitations on the graphics artists. Our graphics engineers had to be able to give us the cleverest solutions they could come up with so that we could maintain our performance while at the same time being able to use these very, very clever solutions without needing to expose the artists to the technical constraints of needing to use these shaders. So any solution for the texturing pipeline needed to involve the complete removal of any manual packing for artists. Secondary to that, of course, we wanted to support all the art software natively, Substance Painter, Substance Designer, Photoshop, but that's really secondary to that. And then lastly, and it's least important in this list of points, but certainly not trivial, we needed to automate engine imports as well. We want to make sure that when an artist presses export, it makes its way to Unreal in this case. These are all Unreal images, and all the images you see in these presentations are from Unreal, is worth mentioning. But of course, we want things to get there automatically, or as automatically and smoothly as possible. So these are all the goals we set. That brings us to our MVP. Again, we're here to talk about the art of the MVP. What's the single most simplistic way of solving this immediate problem that we have? We cannot have an artist go into Photoshop and turn a color mask into 8 1-bit images to then manually pack it into one 8-bit image. I don't think Photoshop can even do that. So no manual packing and unlimited capacity for shader complexity. That's our goal. And as you can see on the right, we have many shaders applied to our characters, and they're all very complex. Which brings us to an overview of the process we're looking at. So from left to right, we got our software where the artist makes the textures. We then have the export step where the artist produces some images that are going to be packed. We then have the packing step where these images are turned into whatever specification the shader requires. We then have the import step where the artist puts the images into the engine, and finally assigning the textures to our shader. On the left, we see all of that is outside of the engine. On the right, we see all of that is in the engine, which means it leaves us with a bit of a keystone. You could call it a foundational, very much a critical part of our process, which is the packing textures step. Now, we knew we needed to solve this for all of these software packages over time, Painter, Designer, and Photoshop. So we also knew that we needed to have something up and running in about 2 weeks because this was very early pre-production and we needed something. So we came up with this. This was a standalone application, completely independent of Substance Painter, Designer, Photoshop, 3ds Max, Maya, any of these applications because it doesn't run in them. This ran completely separate without being integrated into anything. Obviously, not super convenient, but it's also not dependent on anything. That allowed us to deliver this extremely quickly. The artist would simply export their textures individually, completely unpacked, and then manually assign each of them to each of these individual slots that would be exposed to the artist based on the shader that they chose. Basically, they're saying, I have a bunch of textures, I don't know how to pack them, choose a shader, press pack, and you're done. It would automatically do version control for you, perforce integration and all of that, and that was all fairly straightforward. As a result of this being very simple and expandable for the tech artists, this lasted us for about 6 months during very early concept phase. That brings us to an MVP of this keystone. Quite good. We could stop here. Let's not. Which brings us to version 2, first native integration into Substance Painter. Everyone was super excited because Substance Painter is where artists live. That's where they like to live. Tech artists are less excited about Substance Painter. But it does do the job. It packs the textures automatically when you press export. And this is where we get our first instance of chasing simplicity. We started to gradually deprecate the standalone app because much as I liked it, it's not great. We know that manually assigning each of these textures is not super convenient. Yes, we can reduce friction by automatically picking the other textures for that particular slot based on naming conventions and all of that, but it gets really inconvenient. So we knew we wanted packing to just happen in a way that artists don't even need to know that it happens, which gives us this. This version is very simplistic. It didn't include anything to do with sending textures directly to Unreal, and it was not supported in Photoshop or Substance Designer. As such, the lifespan of this is only really about 3 months, but it built a foundation and it allowed us to form a bit of a vision and an idea of where we wanted to go medium to long term. So that gives us an MVP of all the things on the left. At this point, we'd already completely rewritten the packing texture step because obviously, the second you use something, you figure out that the way you chose to implement the first version is completely and utterly wrong, and you kind of curse yourself, but that's how development works. But of course, MVP only for Painter, not for Designer in Photoshop, so we knew we needed to do some more work. Version 3 then, integrations, everything became supported. This lasted us for about a year because we did what effectively was a demo of our game for internal use, with these integrations where artists would actually be able to use these. This came with an initial implementation of Send to Unreal, but because the initial implementation of Send to Unreal was quite, shall we say, buggy, unstable, we had to re-implement it from the ground up. So that particular module, to use the modular terminology, was completely ripped out. So we had to actually remove a feature in order to re-implement it better. Took us about a month to re-implement it completely because it came with a much bigger framework to interact remotely with any instance of the Unreal Editor, which obviously is useful for other purposes as well, not just textures. But it took us quite a while to re-implement that properly. Again, chasing simplicity. That gives us version 3 really for all of the boxes on the left, and an MVP for our import texture step. Now this basically gives us a global idea of everything we currently want to address. The assign to shader box will remain unchecked, at least in the current version of our tools, because we don't really want to deal with that. There's so many permutations, so many potential options, parameters to deal with. It's a very complex problem to solve. We don't really want to touch that. But we knew that we needed to do one more version because obviously our import texture step, a bit unstable, a bit unreliable, a bit simplistic, which brings us to the version that we have today. Complete rework. This was done over the course of about 2 months, although the actual refactor to turn this version, to turn our previous version of the exporter into this one took only about 2 weeks. But the reason it took 2 months in the background is because it came off the back of a lot of other engineering work that was done in parallel. We completely rebuilt all of our UI code, which allowed us to nest containers with multiple settings, with multiple advanced settings, including import settings for Unreal so that artists didn't have to set up things like compression settings, texture groups, maximum texture size, which again prevented them from running into validators because obviously we validate everything, or at least everything we know how to validate. That was quite annoying for artists, but we want them to be there. So we guide them so that they never run into them anyway. The refactor for that, as I said previously, only took about 2 weeks, and that's because all of these things, all of these modules were built separately. We've got the UI layer, we've got the function layer, the version control layer, asset database layer. All of these layers exist independently from each other, and they're just composed in the form of an exporter, but they can be used individually. The initial version of this release, however, actually reduced functionality. Again, the symbol reappears. When we initially released this, it was quite buggy, as an initial version will do. But because we rebuilt so many of the building blocks, obviously we had to reduce some of the functionality that was previously there. The reason we had to do that was because the code was simply untenable and we could not get it out in a stable form without reducing some of the more advanced functions or completely removing these functions. They were, however, very quickly restored. Within the span of a week, we were back up to our previous functionality, and a week after that, we were way beyond where we were before. Which gives us what we have today, version 4 of all of these boxes. Now, take special note about the fact that all of these boxes were addressed individually, and that they were addressed as individual problems that stand by themselves. The pack texture step is performed purely in code and has no dependency on Substance Painter, Designer, Photoshop, or anything like that. And as such, it could theoretically run in Maya, Blender, Marmoset. As a result, our export texture step is the only thing that actually interacts with the application interface itself. This is where we just get the application to get the images out of the application itself, pack the textures, and everything else happens completely agnostic. Great, good, very good for us. So we put this into action. This is where we get to see the pretty images. The boring part is over, so thanks for still being here. This is where we put things into action. Our character artists at this point, now that they've gotten familiar with this more advanced version of the tools and were able to actually consistently get things into the engine, they started to break down the image that they wanted for our graphics artists. Again, we return to the theme of we want potentially unlimited complexity in our shaders. So this is an early version of our Thor character, where we wanted to have all of these effects that are displayed on the left. We also wanted mesh upgrades, texture upgrades, iterations on basically every aspect of the character. So the character artists took about a month, started working with the graphics engineers, and then in cooperation with TechArt, we were able to drastically improve the quality of our shaders and our art, which resulted in this. I don't think anyone here can make any argument that that's not an improvement. That's quite a drastic improvement. But as you can see, as you may be able to see, from left to right, there are not only more complex shaders, but more shaders. As a direct result, the tools needed to be in a good, stable state for us to be able to achieve this level of quality. Quality, after all, is a direct result of iteration and iteration speed. So the tools being as good as they were at the time allowed the artists to iterate quickly and produce more versions and more prototypes to illustrate to the graphics artists what they needed. And likewise, the graphics artists were able to come up with extremely complex shaders without the character artists needing to necessarily care about that complexity. So there are some lessons to be drawn here. First, what we did right, I think at least, is that we prioritized understanding the problem rather than coming up with the solution from day one. That was not necessarily our goal. We just needed to know what it is we need to do, what's the spirit, what's the essence of what we need to solve. In doing so, we were also not afraid of refactors. We regularly tore everything down and started from the ground up because we knew that was the right thing to do. We also removed technical constraints from our graphics artists. As we've seen, our shaders are highly complex. But the graphics artists were able to get that complexity and really flex their graphics engineer muscles without needing to really care about what it would do to our artists. Obviously, not everything went perfectly. Some prototypes were a dead end. There are some of the early iterations of the Send to Unreal functionality, in fact, was so unstable that artists lost faith in that system, and they started to untick that box that would automatically send textures to Unreal during the export process. That basically destroyed faith that this system functioned, and therefore artists started forgetting that it even existed. New starters were not told. And so after we re-implemented it from the ground up, we had to do a big campaign to advertise, hey, this is a thing that exists. It's good for you because you won't run into all of these error messages that your textures are set up incorrectly in Engine. If you just check this box, it'll do all of that for you, and you can save like 10 minutes of work every time you press export, which is great. Obviously, also code always gets bloated over time. This is just development, and it needs trimming. So we are doing that. I'm currently in the process of doing yet another refactor, so that'll be version 5. But obviously, the scale of the refactors gets less over time as more of the individual components settle into a pretty good version. There's also, obviously, it's a big project, it's a big team, there's things we didn't show. All features mentioned here were heavily supported by a lot of engineering effort. We've got entire teams building systems that make it easier for us to integrate with the content in the editor. We are now able to remotely control our Unreal editor instance pretty much in an unlimited fashion, and that would not have been possible without the help of our engineers. Also, the asset database was mentioned. We have an entire asset management backend system that allows us to have a custom asset browser in 3ds Max, Maya, Substance Painter, Substance Designer, and all of that would also not have been possible without a lot of support. And obviously, this is art. It's the artist doing the job. So all of the art you saw here was only as good as it was because we have world-class artists.